Hello and welcome to this Writing 3030 presentation as part of the Spring 2017 Conference on Innovations in Science and Technology. My name is Tim Brown and I am a senior undergraduate psychology student here at the University of Colorado at Boulder. I have always had a strong interest in astronomy and physics, so I wanted to share a topic which I find to be absolutely fascinating. Today I will be speaking about the James Webb Space Telescope, a marvel of modern engineering that embodies the spirit of scientific progress, technological advances, and international collaboration between space agencies. The JWST, or the Webb as it is commonly referred to, was built to help us answer some of humanity's deepest questions. I will begin this brief lectures with some of the key features and technical specifications of the James Webb Space Telescope, and will proceed to discuss the profound implications that this device will have on our understanding of the universe. So what exactly is the JWST, or the Webb Telescope? Well, research and development of the James Webb Space Telescope began in 1996, when it was formerly referred to as the Next Generation Space Telescope. The Webb telescope was built over a 20-year period and was the result of the collaboration between NASA, the Canadian Space Agency, and the European Space Agency. These teams set out to design and build, without a doubt, the most powerful space telescope ever constructed. By the time it was completed in 2016, the project was estimated to have cost $8.8 billion, and by the time it reaches its orbital position at the Lagrange 2 point, or L2, the project could exceed $10 billion. So, as a publicly funded enterprise, what do the taxpayers across the globe stand to gain through this telescope? Or in other words, besides theoretical physicists and astronomers, why should anybody care what is going on at the JWST? The short answer to this question, which will be revisited again in this presentation, is that it has the potential to answer existential questions which are deeply ingrained within the human psyche. For example, what occurred at the beginning of time, which we commonly understand to be the Big Bang? Second, what are the origins of life? Are we alone in the universe? And finally, what will the universe look like in another billion years, or 5 billion, or even 10 billion years? These are all wonderful questions, and the teams that are analyzing the JWST data will be looking to answer these questions exactly. In October of 2018, the James Webb Space Telescope will be launched on an Ariane 5 rocket, which is considered to be the world's safest and most reliable rocket for delivering this payload to its destination in space. After launch, the telescope will embark on its 30-day, million-mile journey to its final orbital destination. During this period, the Webb will detach from the Ariane 5 rocket and then will slowly unfold into its fully deployed position through a carefully orchestrated sequence of events. Exhaustive testing has been a critical aspect of the construction of the Webb telescope. Unlike the Hubble, which is accessible in its orbit 570 kilometers above the Earth, the JWST will permanently be out of reach once it embarks on its journey to the L2 point. One thing that I find particularly interesting is the fact that the James Webb Space Telescope will not be in orbit around the Earth. It will actually orbit the Sun. The second Lagrange point, or L2, is a gravitationally stable point located 1.5 million kilometers, or approximately 1.5 million miles away from the Earth. What is special about this orbit is that it lets the telescope stay in line with the Earth as it moves around the Sun. This allows the satellite's large sun shield to protect the telescope from the light and heat of the Sun and stay in constant communication with the Earth. I would like to take a quick look at the following two images, as they are both very relevant to our current understanding of the cosmic timeline of the universe. The image on the right is called the Hubble Ultra Deep Field, and it was released by NASA in 2006. This view of nearly 10,000 galaxies dates back approximately 13 billion years in time. The image required 800 exposures taken over the course of 400 Hubble orbits around the Earth. NASA revised the image in 2012 in the Extreme Deep Field project and revealed a similar image that spans 13.2 billion years in time. Now, as if it wasn't enough to capture a stunning image that has captured photons traveling across the universe for over 13 billion years, ending their journey on the lens of the Hubble, scientists wanted to take another step towards the Big Bang and look a few 100 million years closer to the origin of our universe. This, to me, is one of the most important missions of the Webb telescope. One of the primary missions in the Webb's 5 to 10-year operation is to utilize its infrared devices to search for some of the earliest stars and galaxies formed after the Big Bang. We hope to look as far back as 13.5 billion years in time, which is a mere 300 million years after the origin of the universe. The exploration of protoplanetary disks will play a pivotal role in improving our understanding of how solar systems form. A protoplanetary disk is a rotating ring composed of gas, dust, ice, and rock from which planets form over periods of millions to billions of years. The Webb will use transit spectroscopy to analyze various properties of exoplanets, which is any planet orbiting a star other than our own. This process involves the analysis of light traveling over the surface of distant planets as it passes in front of the star that it is orbiting. This allows us to detect what a planet is composed of and whether or not it has an atmosphere. Another goal will be to observe the formation of planetary systems and investigate the potential for life in these exoplanets. Because planetary formation is a process that requires millions to billions of years, we must collect data from many systems in various stages of their development to gain a deeper understanding of the life of stars and their orbiting planets. The Webb telescope will use a similar process to learn more about how galaxies form and evolve over time. Galaxy formation is another process that unfolds over billions of years. We will never be able to detect real-time changes in our lifetimes. Instead, we must look at many galaxies in various stages of their development. In doing so, it is possible to interpolate these data points to create accurate computer simulations of the process of galaxy formation and interactions between galaxies that cross paths over an immense period of time. The Webb will be the largest telescope ever launched into orbit. Its primary mirror is approximately 6 times larger than that of the Hubble, and although larger telescopes exist on Earth, their deep space capabilities are limited by the relative opacity of Earth's atmosphere. This modern, brilliantly engineered craft has been designed to endure the harsh conditions of space. In fact, the near 0-degree temperatures will actually improve the precision and resolution of the images it captures. The Webb Space Telescope will revolutionize the way that we look into the cosmos. JWST will enhance our ability to explore not only our own solar system, but to search the cosmos for exoplanets similar to Earth in their size, atmospheric conditions, and temperature. Using new infrared technologies, we may find evidence of life in distant galaxies over the next decade. The JWST is a perfect symbol of the uniquely human capacity to contemplate our own existence and our innate desire to explore and understand the mysteries of not only our Earth, but the entire universe. I hope that the data collected from the Webb telescope will assist in bridging the gaps in our standard model of particle physics and lead us towards a theory of everything that unifies the 4 fundamental forces of nature. Whether or not the James Webb Space Telescope discovers habitable planets in distant galaxies, assists in our understanding of the origin of the universe, or simply provides some stunning images of ancient celestial bodies, one fact is certain. This telescope represents the great lengths that humans will go to understand and explore the universe in which we live. Thank you for your time and good night.